If you take another look at the form tag in your view, you can see that its method attribute is set to post. Moreover, the form doesn't declare an action attribute. This means that when the form is submitted, the browser will gather all the data in the form and send it to the server in an HTTP post request to the same path for which a GET request displayed the form, the /design path. Therefore, you need a controller handler method on the receiving end of that post request. You need to write a new handler method in design taco controller that handles a post request for /design. In listing 2.4, you used the @getMapping annotation to specify that the showDesignForm method should handle HTTP GET requests for /design. Just like @getMapping handles GET requests, you can use @postMapping to handle post requests. For handling taco design submissions, add the process taco method in the following listing to design taco controller. As applied to the process taco method, @postMapping coordinates with the class level @requestMapping to indicate that process taco should handle post requests for /design. This is precisely what you need to process a taco artist's submitted creations. When the form is submitted, the fields in the form are bound to properties of a taco object, whose class is shown in the next listing, that's passed as a parameter into process taco. From there, the process taco method can do whatever it wants with the taco object. In this case, it adds the taco to the taco order object passed as a parameter to the method and then logs it. The @model attribute applied to the taco order parameter indicates that it should use the taco order object that was placed into the model via the @model attribute annotated order method shown earlier in listing 2.4. If you look back at the form in listing 2.5, you'll see several checkbox elements, all with the name ingredients, and a text input element named name. Those fields in the form correspond directly to the ingredients and name properties of the taco class. The name field on the form needs to capture only a simple textual value. Thus, the name property of taco is of type string. The ingredients checkboxes also have textual values, but because 0 or many of them may be selected, the ingredients property that they're bound to is a list ingredient that will capture each of the chosen ingredients. But wait, if the ingredients checkboxes have textual, for example, string values, but the taco object represents a list of ingredients as list ingredients, then isn't there a mismatch? How can a textual list like an array of strings FLTO, GRBF, LETC be bound to a list of ingredient objects that are richer objects containing not only an ID, but also a descriptive name and ingredient type? That's where a converter comes in handy. A converter is any class that implements Spring's converter interface and implements its convert method to take one value and convert it to another. To convert a string to an ingredient, we'll use the ingredient by ID converter as follows. Because we don't yet have a database from which to pull ingredient objects, the constructor of ingredient by ID converter creates a map keyed on the string that is the ingredient ID and whose values are ingredient objects. In Chapter 3, we'll adapt this converter to pull the ingredient data from a database instead of being hard-coded like this. The convert method then simply takes a string that is the ingredient ID and uses it to look up the ingredient from the map. Notice that the ingredient by ID converter is annotated with @component to make it discoverable as a bean in the Spring application context. Spring Boot auto-configuration will discover this and any other converter beans, and will automatically register them with Spring MVC to be used when the conversion of request parameters to bound properties is needed. For now, the process taco method does nothing with the taco object. In fact, it doesn't do much of anything at all. That's okay. In Chapter 3, you'll add some persistence logic that will save the submitted taco to a database. Just as with the showDesignForm method, process taco finishes by returning a string value. And just like showDesignForm, the value returned indicates a view that will be shown to the user. But what's different is that the value returned from process taco is prefixed with redirect, indicating that this is a redirect view. More specifically, it indicates that after process taco completes, the user's browser should be redirected to the relative path /orders/current. The idea is that after creating a taco, the user will be redirected to an order form from which they can place an order to have their taco creations delivered. But you don't yet have a controller that will handle a request for /orders/current. Given what you now know about @controller, @request mapping, and @get mapping, you can easily create such a controller. It might look something like the following listing. Once again, you use Lombok's @slf4j annotation to create a free slf4j logger object at compile time. You'll use this logger in a moment to log the details of the order that's submitted. The class level @request mapping specifies that any request handling methods in this controller will handle requests whose path begins with /orders. When combined with the method level @get mapping, it specifies that the order form method will handle HTTP GET requests for /orders/current. As for the order form method itself, it's extremely basic, only returning a logical view name of order form. Once you have a way to persist taco creations to a database in Chapter 3, you'll revisit this method and modify it to populate the model with a list of taco objects to be placed in the order. The order form view is provided by a time-leaf template named orderform.html, which is shown next. For the most part, the orderform.html view is typical HTML/timeleaf content, with very little of note. It starts by listing the tacos that were added to the order. It uses timeleaf's th:"each to cycle through the order's tacos property as it creates the list. Then it renders the order form. But notice that the form tag here is different from the form tag used in listing 2.5, in that it also specifies a form action. Without an action specified, the form would submit an HTTP post request back to the same URL that presented the form. But here, you specify that the form should be posted to /orders, using timeleaf's @braces operator for a context-relative path. Therefore, you're going to need to add another method to your order controller class that handles post requests for /orders. You won't have a way to persist orders until the next chapter, so you'll keep it simple here, something like what you see in the next listing. When the process order method is called to handle a submitted order, it's given a taco order object whose properties are bound to the submitted form fields. Taco order, much like taco, is a fairly straightforward class that carries order information. In the case of this process order method, the taco order object is simply logged. We'll see how to persist it to a database in the next chapter. But before process order is done, it also calls setComplete on the session status object passed in as a parameter. The taco order object was initially created and placed into the session when the user created their first taco. By calling setComplete, we are ensuring that the session is cleaned up and ready for a new order the next time the user creates a taco. Now that you've developed an order controller and the order form view, you're ready to try it out. Open your browser to http://localhost:8080/design. Select some ingredients for your taco and click the Submit Your Taco button. You should see a form similar to what's shown in Figure 2.4. Fill in some fields in the form and press the Submit Order button. As you do, keep an eye on the application logs to see your order information. When I tried it, the log entry looked something like this, reformatted to fit the width of this page. It appears that the process order method did its job, handling the form submission by logging details about the order. But if you look carefully at the log entry from my test order, you can see that it let a little bit of bad information get in. Most of the fields in the form contained data that couldn't possibly be correct. Let's add some validation to ensure that the data provided at least resembles the kind of information required. Section 2.3. Validating Form Input. When designing a new taco creation, what if the user selects no ingredients or fails to specify a name for their creation? When submitting the order, what if the user fails to fill in the required address fields? Or what if they enter a value into the credit card field that isn't even a valid credit card number? As things stand now, nothing will stop the user from creating a taco without any ingredients, or with an empty delivery address, or even submitting the lyrics to their favorite song as the credit card number. That's because you haven't yet specified how those fields should be validated. One way to perform form validation is to litter the process taco and process order methods with a bunch of if-then blocks, checking each and every field to ensure that it meets the appropriate validation rules. But that would be cumbersome and difficult to read and debug. Fortunately, Spring supports the Java Bean Validation API, also known as JSR 303. See this link. This makes it easy to declare validation rules, as opposed to explicitly writing declaration logic in your application code. To apply validation in Spring MVC, you need to add the Spring Validation Starter to the build. Declare validation rules on the class that is to be validated, specifically the taco class. Specify the validation should be performed in the controller methods that require validation, specifically the design taco controller's process taco method and the order controller's process order method. Modify the form views to display validation errors. The Validation API offers several annotations that can be placed on properties of domain objects to declare validation rules. Hibernate's implementation of the Validation API adds even more validation annotations. Both can be added to a project by adding the Spring Validation Starter to the build. The validation checkbox under I/O in the Spring Boot Starter wizard will get the job done. But if you prefer manually editing your build, the following entry in the Maven pom.xml file will do the trick. Or if you're using Gradle, then this is the dependency you'll need. Is the validation starter required? In early versions of Spring Boot, the Spring Validation Starter was automatically included with the Web Starter. Starting with Spring Boot 2.3.0, you'll need to explicitly add it to your build if you intend to apply validation. With the Validation Starter in place, let's see how you can apply a few annotations to validate a submitted taco or taco order. Section 2.3.1, Declaring Validation Rules. For the taco class, you want to ensure that the name property isn't empty or null, and that the list of selected ingredients has at least one item. The following listing shows an updated taco class that uses @notNull and @size to declare those validation rules. You'll notice that in addition to requiring that the name property isn't null, you declare that it should have a value that's at least 5 characters in length. When it comes to declaring validation on submitted taco orders, you must apply annotations to the taco order class. For the address properties, you want to be sure that the user doesn't leave any of the fields blank. For that, you'll use the @notBlank annotation. Validation of the payment fields, however, is a bit more exotic. You need to ensure not only that the CC number property isn't empty, but also that it contains a value that could be a valid credit card number. The CC expiration property must conform to a format of MM/YY, 2-digit month and year, and the CC CVV property needs to be a 3-digit number. To achieve this kind of validation, you need to use a few other Java Bean Validation API annotations and borrow a validation annotation from the Hibernate Validator collection of annotations. The following listing shows the changes needed to validate the taco order class. As you can see, the CC number property is annotated with @credit card number. This annotation declares that the property's value must be a valid credit card number that passes the Loon algorithm check. See this link. This prevents user mistakes and deliberately bad data, but doesn't guarantee that the credit card number is actually assigned to an account or that the account can be used for charging. Unfortunately, there's no ready-made annotation for validating the MMYY format of the CC expiration property. I've applied the @pattern annotation, providing it with a regular expression that ensures that the property value adheres to the desired format. If you're wondering how to decipher the regular expression, I encourage you to check out the many online regular expression guides. including at this link. Regular expression syntax is a dark art and certainly outside the scope of this book. Finally, we annotate the CC/CVV property with @digits to ensure that the value contains exactly 3 numeric digits. All of the validation annotations include a message attribute that defines the message you'll display to the user if the information they enter doesn't meet the requirements of the declared validation rules. Section 2.3.2 Performing Validation at Form Binding. Now that you've declared how a taco and taco order should be validated, we need to revisit each of the controllers, specifying that validation should be performed when the forms are posted to their respective handler methods. To validate a submitted taco, you need to add the Java Bean Validation API's @valid annotation to the taco argument of the design taco controller's process taco method as shown next. The @valid annotation tells Spring MVC to perform validation on the submitted taco object after it's bound to the submitted form data and before the process taco method is called. If there are any validation errors, the details of those errors will be captured in an errors object that's passed into process taco. The first few lines of process taco consult the errors object, asking its hasErrors method if there are any validation errors. If there are, the method concludes without processing the taco and returns the design view name so that the form is redisplayed. To perform validation on submitted taco order objects, similar changes are also required in the process order method of the order controller, as shown in the next code listing. In both cases, the method will be allowed to process the submitted data if there are no validation errors. If there are validation errors, the request will be forwarded to the form view to give the user a chance to correct their mistakes. But how will the user know what mistakes require correction? Unless you call out the errors on the form, the user will be left guessing about how to successfully submit the form. Section 2.3.3 Displaying Validation Errors. TimeLeaf offers convenient access to the errors object via the fields property and with its th:_errors attribute. For example, to display validation errors on the credit card number field, you can add a span tag element that uses these error references to the order form template as follows. Aside from a class attribute that can be used to style the error so that it catches the user's attention, the span tag element uses a th::if attribute to decide whether to display the span tag. The fields property's hasErrors method checks whether there are any errors in the CC number field. If so, the span tag will be rendered. The th::errors attribute references the CC number field, and assuming errors exist for that field, it will replace the placeholder content of the span tag element with the validation message. If you were to sprinkle similar span tags around the order form for the other fields, you might see a form that looks like figure 2.5 when you submit invalid information. The errors indicate that the name, city, and zip code fields have been left blank, and that all of the payment fields fail to meet the validation criteria. Now your Taco Cloud controllers not only display and capture input, but they also validate that the information meets some basic validation rules. Let's step back and reconsider the home controller from Chapter 1, looking at the alternative implementation. Section 2.4 Working with View Controllers. Thus far, you've written 3 controllers for the Taco Cloud application. Although each controller serves a distinct purpose in the functionality of the application, they all pretty much adhere to the following programming model. They're all annotated with @controller to indicate that they're controller classes that should be automatically discovered by Spring component scanning and instantiated as beans in the Spring application context. All but home controller are annotated with @request mapping at the class level to define a baseline request pattern that the controller will handle. They all have one or more methods that are annotated with @getMapping or @postMapping to provide specifics on which methods should handle which kinds of requests. Most of the controllers you'll write will follow that pattern, but when a controller is simple enough that it doesn't populate a model or process input, As is the case with your home controller, there's another way that you can define the controller. Have a look at the next listing to see how you can declare a view controller, a controller that does nothing but forward the request to a view. The most significant thing to notice about WebConfig is that it implements the WebMVC configurer interface. WebMVC configurer defines several methods for configuring Spring MVC. Even though it's an interface, it provides default implementations of all the methods, so you need to override only the methods you need. In this case, you override Add View Controllers. The Add View Controllers method is given a View Controller registry that you can use to register one or more view controllers. Here, you call Add View Controller on the registry, passing the /, which is the path for which your view controller will handle GET requests. That method returns a View Controller registration object, on which you immediately call setViewName to specify home as the view that a request for / should be forwarded to. And just like that, you've been able to replace Home Controller with a few lines in a configuration class. You can now delete Home Controller, and the application should still behave as it did before. The only other change required is to revisit Home Controller test from Chapter 1, removing the reference to Home Controller from the @WebMVC test annotation, so that the test class will compile without errors. Here, you've created a new WebConfig configuration class to house the View Controller declaration. But any configuration class can implement WebMVC configurer and override the Add View Controller method. For instance, you could have added the same View Controller declaration to the Bootstrap Taco Cloud application class like this. By extending an existing configuration class, you can avoid creating a new configuration class, keeping your project artifact count down. But I prefer creating a new configuration class for each kind of configuration: web, data, security, and so on, keeping the application Bootstrap configuration clean and simple. Speaking of view controllers, and more generically, the views that controllers forward requests to, so far you've been using Timeleaf for all your views. I like Timeleaf a lot, but maybe you prefer a different template model for your application views. Let's have a look at Spring's many supported view options. Section 2.5. Choosing a view template library. For the most part, your choice of a view template library is a matter of personal taste. Spring is flexible and supports many common templating options. With only a few small exceptions, the template library you choose will itself have no idea that it's even working with Spring. Footnote 3. One such exception is Timeleaf's Spring Security Dialect, which we'll talk about in Chapter 5. Table 2.2 catalogs the template options supported by Spring Boot auto-configuration. Generally speaking, you select the view template library you want, add it as a dependency in your build, and start writing templates in the /templates directory under the src/main/resources directory in a Maven or Gradle project. Spring Boot detects your chosen template library and automatically configures the components required for it to serve views for your Spring MVC controllers. You've already done this with Timeleaf for the Taco Cloud application. In Chapter 1, you selected the Timeleaf checkbox when initializing the project. This resulted in Spring Boot's Timeleaf starter being included in the pom.xml file. When the application starts up, Spring Boot auto-configuration detects the presence of Timeleaf and automatically configures the Timeleaf beans for you. All you had to do was start writing templates in /templates. If you'd rather use a different template library, you simply select it at Project Initialization or edit your existing project build to include the newly chosen template library. For example, let's say you wanted to use Mustache instead of Timeleaf. No problem. Just visit the project pom.xml file and replace this with this. Of course, you'd need to make sure that you write all the templates with Mustache syntax instead of Timeleaf tags. The specifics of working with Mustache, or any of the template language choices, is well outside the scope of this book, but to give you an idea of what to expect, here's a snippet from a Mustache template that will render one of the ingredient groups in the taco design form. This is the Mustache equivalent of the Timeleaf snippet in section 2.1.3. The hash wrap surrounded with double braces block, which concludes with /wrap surrounded with double braces, iterates through a collection in the request attribute whose key is wrap and renders the embedded HTML for each item. The ID surrounded with double braces and name surrounded with double braces tags reference the ID and name properties of the item, which should be an ingredient. You'll notice in Table 2.2 that JSP doesn't require any special dependency in the build. That's because the servlet container itself, Tomcat by default, implements the JSP specification, thus requiring no further dependencies. But there's a gotcha if you choose to use JSP. As it turns out, Java servlet containers, including embedded Tomcat and Jetty containers, usually look for JSPs somewhere under /web-inf. But if you're building your application as an executable jar file, there's no way to satisfy that requirement. Therefore, JSP is an option only if you're building your application as a WAR file and deploying it in a traditional servlet container. If you're building an executable jar file, you must choose Timeleaf, FreeMarker, or one of the other options in Table 2.2. Section 2.5.1 Caching Templates. By default, templates are parsed only once, when they're first used, and the results of that parse are cached for subsequent use. This is a great feature for production because it prevents redundant template parsing on each request and thus improves performance. That feature is not so awesome at development time, however. Let's say you fire up your application, hit the Taco design page, and decide to make a few changes to it. When you refresh your web browser, you'll still be shown the original version. The only way you can see your changes is to restart the application, which is quite inconvenient. Fortunately, we have a way to disable caching. All we need to do is set a template-appropriate caching property to false. Table 2.3 lists the caching properties for each of the supported template libraries. By default, all of these properties are set to true to enable caching. You can disable caching for your chosen template engine by setting its cache property to false. For example, to disable Timeleaf caching, add the following line in application.properties. The only catch is that you'll want to be sure to remove this line, or set it to true, before you deploy your application to production. One option is to set the property in a profile. We'll talk about profiles in Chapter 6. A much simpler option is to use Spring Boot's DevTools, as we opted to do in Chapter 1. Among the many helpful bits of development time help offered by DevTools, it will disable caching for all template libraries, but will disable itself and thus re-enable template caching when your application is deployed. Summary. Spring offers a powerful web framework called Spring MVC that can be used to develop the web front end for a Spring application. Spring MVC is annotation-based, enabling the declaration of request handling methods with annotations such as @requestMapping, @getMapping, and @postMapping. Most request handling methods conclude by returning the logical name of a view, such as a Timeleaf template, to which the request, along with any model data, is forwarded. Spring MVC supports validation through the Java Bean Validation API, and implementations of the validation API such as Hibernate Validator. View controllers can be registered with Add View Controller in a Web MVC Configurer class to handle HTTP GET requests for which no model data or processing is required. In addition to Timeleaf, Spring supports a variety of view options, including FreeMarker, Groovy templates, and Mustache. Chapter 3. Working with Data. This chapter covers using Spring's JDBC template, creating Spring Data JDBC repositories, declaring JPA repositories with Spring Data. Most applications offer more than just a pretty face. Although the user interface may provide interaction with an application, it's the data it presents and stores that separates applications from static websites. In the Taco Cloud application, you need to be able to maintain information about ingredients, tacos, and orders. Without a database to store this information, the application wouldn't be able to progress much further than what you developed in Chapter 2. In this chapter, you're going to add data persistence to the Taco Cloud application. You'll start by using Spring support for JDBC, Java Database Connectivity, to eliminate boilerplate code. Then you'll rework the data repositories to work with JPA, Java Persistence API, eliminating even more code. Section 3.1, Reading and Writing Data with JDBC. For decades, relational databases and SQL have enjoyed their position as the leading choice for data persistence. Even though many alternative database types have emerged in recent years, the relational database is still a top choice for general-purpose data store and will not likely be usurped from its position anytime soon. When it comes to working with relational data, Java developers have several options. The two most common choices